this video, we're going to simplify expressions involving square roots and fractions. These types of expressions are often seen as solutions to quadratic equations. Since these expressions have both square roots and fractions, we will have to make sure that in terms of simplification and what that means here, we will have to simplify both the square root and the fraction. So the first thing we'll do is simplify square roots. And then if possible, we'll also simplify the fraction. And sometimes the process of simplifying the square root makes it so that the fraction can then be simplified. In these immediate expressions, the fraction would not be able to be simplified in either of these. So let's get started with this first one. The expression that we have is, in the numerator, we have 4 plus the square root of 12, and then in the denominator we have 2. So to start, we're going to simplify that square root. The square root of 12, when we simplify that, we're looking to break it down so that the number inside that radical is smaller. If it has a perfect square factor, then we'll be able to do this. And 12 has 4 as a factor, so we'll be able to simplify the square root of 12 using that. So we'll turn this into, and in the numerator we're going to keep that 4 plus. We're going to have 4 plus, and then instead of the square root of 12, we're going to write it as the square root of 4 times 3. And that is still all divided by 2. Now, by breaking that down into the square root of 4 times 3, we can break it down one step further using the multiplication property for square roots. And we'll do that, we'll turn this numerator then into 4 plus, and then instead of the square root of 4 times 3, we'll make it the square root of 4 times the square root of 3. And again, that's still all divided by 2. Now, what we've done is made it so that we have a product, and the square root of 4 can just be written as 2. So in this numerator, we'll now simplify to 4 plus 2 times the square root of 3. And that whole thing is divided by 2. At this point, the radical is simplified. Now, though, we can see that the numerator and denominator have a common factor. And the factor that's common to the entire numerator and the entire denominator is 2. I see that I have 4 as one term in my numerator, and I have 2 times the square root of 3 as another term. My denominator then just contains 2. So what I'm going to look to do is to cancel out a factor of 2. Now, it's important to remember that I have to cancel a factor, and that numerator right now isn't actually factored. So I'll factor out that factor of 2 from the numerator. And so that'll look like 2, I'm factoring that out, and then inside here I'm going to be left with 2 plus the square root of 3. So I have 2 and then parentheses with 2 plus the square root of 3, and then those parentheses close. And that's what's in my numerator right now. Again, the reason I get 2 plus the square root of 3 inside those parentheses, I factored out a 2, so when I do that from 4, I'm left with a 2. And I had 2 times the square root of 3, and when I factor out a 2, I'm simply left with the square root of 3. The denominator here is still 2. So at this point, I have a factor of 2 in my numerator and a factor of 2 in my denominator. And those can cancel out, and that'll just leave a factor of 1 in my denominator. So when I simplify this, I'll just have 2 plus the square root of 3. Okay, so that expression is fully simplified. The radical is simplified, and so is the fraction. Let's move on to our next example. Here, we have in the numerator 6 minus the square root of 18, and then the denominator just contains 6. So again, the first thing that we'll want to do is simplify any square roots, and then when that is completed, we'll look to simplify the fraction itself. So to start, we're going to look to simplify the square root of 18. And to do that, we're going to look for the largest perfect square factor for 18, and that happens to be 9. We can write 18 as 9 times 2. So in our first step here, we're going to write 6 minus, and then instead of the square root of 18, we're going to write the square root of 9 times 2. And that's all divided by 6. Now that we've broken that apart into the square root of 9 times 2, we can apply the multiplication property for square roots. So this will become 6 minus, and then instead of that square root of the product of 9 times 2, we'll write the square root of 9 times the square root of 2. And that whole thing is divided by 6. Now, again, our motivation for breaking that down into a perfect square factor was that the square root of 9 is just the number 3. So now our numerator can be written as 6 minus 3 times the square root of 2. And again, that's all divided by 6. So at this point, the radical is fully simplified, and we need to look to see if the fraction itself can simplify further. What we're looking for are factors that are common to the entire numerator and the entire denominator. Our numerator is not factored, so we'll look to do that. And in the numerator, we have the terms 6, and then we have negative 3 square root 2. Those have as a common factor 3. So I'll factor that out, and then I'll look to notice that that will cancel. There will be a factor of 3 in the denominator that also cancels. So factoring out that 3, I'm going to put 3, and then inside parentheses, I had the expression 6 minus 3 times the square root of 2. So now when I factor out 3, inside those parentheses I'm left with 2 minus the square root of 2. And again, that's all divided by 6. So now I have a factor of 3 in that numerator, and I still have 6 in my denominator. So that factor of 3 will cancel from each of the numerator and denominator. When it cancels from the denominator, I'm going to be left with just 2 down below. So when this expression is fully simplified, that numerator is going to contain 2 minus the square root of 2, and the denominator will just be a 2. One thing we want to note is that this expression is fully simplified. The radical is fully simplified, and so is the fraction. We may be tempted to want to simplify that 2 in the numerator with the 2 in the denominator, but that 2 in the numerator is a term. It's something that's being added. It's not a factor. If this were broken up, I'll write a little extra here. If we broke this up into 2 over 2 minus the square root of 2 over 2, we would see that it could simplify to 1 minus the square root of 2 over 2. But there's no way to take that square root of 2 and eliminate its denominator.